Welcome to another episode and video on my Arduino Yun version 1, where I try to get some data acquisition from electronics and mechatronics. The Arduino Yun version 1 is equipped with embedded Linux, which enables me to connect it to a network and connect it to some USB storage. And that acquisition, well, not acquisition, but actuating a motor, actuating also this motor with chain, but also acquisition by shining upon phototransistor, which then through this voltage divider gets some signal, although I skip the voltage divider now because the voltage is otherwise too low. And then supposed to go through the wires and then into data array. Last time I ended with this LED burning, and I needed the schematics to see that I had put it here in the wrong port. It was in port 0 and it needed to be in port 6, so that is correct now. What else? Well, actually I don't know yet. One of the things is that I need a signal on here. That can only be done by shining a nice light right here, which I can't show you now, but on the oscilloscope nothing is being shown. So if I now disable this motor, let's take this one, and now, okay, let me show you right there, and mind the purple one, the second from the bottom. This is now actually showing on the oscilloscope. It didn't before. So if I look at the rest, with this I need to see it in the data. However, this was built on a previous experiment where the light came from under, but the 5 volts was way too low for that lamp to have an equal force like this. So how to do this exactly to keep a lamp like this right here, while you actually need to shine right here, because if I do it here just slightly above it, it's already well, you see something, but it's not really noticeable, and I don't even know if you can see it. So this is on top and this is slightly above. There is a difference, but not that I say, that's nice. And one thing to notice is that a phototransistor like this one is actually a switch, a digital switch, which is light dependent. Well, a switch is normally on and off. So if I consider that with the voltage difference that I see on the oscilloscope, I wonder how much detail on signal is being recorded. So Let's get ahead and see whatever can be done with that. Okay, so there is a session with Linux via Linux. Okay, let's see on this one. And it should actually be this, which is not today, so I'll have to remove it. Remove, gone. Okay, I haven't yet opened a session with the data file or with the data. What I did do is make a slight modification right here, so the flashlight can stand, and I stopped the motor. Well, I already did that, but that's fine for now. So now I can, as you can see right here, make that happen. This is also solved, as I told before. That is this one, which goes here, and 5 is number 6, so that works better now. Then data acquisition once again, and now the characteristical sound of the motor will not be heard. Hopefully it will be for this motor, this one. And in order to do that, enter password. There we go. Another point is, I want a signal. Usually I already have one. So let me put this aside a bit. And alright, that's better. Oh, and here for this one there was a problem last time. I didn't get the signal. So let's hope that I do get a signal now. That and I mean not really signal, but the voltage level. Oh wait, I should give some data. Okay, here is something wrong, which needs further investigation. Why doesn't this potmeter show anything? Let me take the potmeter out. That looks good. So I will put it back in. Which doesn't work nicely, by the way. And it needs to contact this one for power, this one for ground, and this one for the remaining voltage to be measured. Alright, now let's see. The probe should detect things, and data is still running. Still nothing. Okay, what I have to do is grab another probe, although it's strictly unnecessary. to test whether the probe is broken, but I doubt it, because with other experiments so far it worked. Although now you can see that this one has full signal. Okay. So there is something not quite right. Okay, that's also not nice. I need to keep this one attached. But this will be the second probe to be broken. But on the other hand, oh wait, let me do something else. Let me put it to slope. Although that would be strictly necessary, but let's see if this wait a minute. See, and now neither of the probes are doing something. Alright, this is a bad contact. So blue works. But somehow the yellow probe has a problem. Okay, let's detach this one and put it back to the place where it was, which is attached to an LED. Getting a pulse modulation somehow right here. But this is not good. What I can also do is attach it to another let's say this LED. Alright, and now when I press it, it should immediately act. Okay, here is, I probably have to calibrate it. And this is taking a lot of time, as you can see. One probe gone. Well, not acting properly. And I want to do more things like how is it going in Octave. But you know, if you watch my videos, things don't always work out the way I intend. Alright, I just found out that it has something to do with the oscilloscope channel, which is the point where the signal enters the oscilloscope. So the entrance corresponding to this signal has a problem. Unfortunately, not the probe, the oscilloscope. Alright, how to go on? Well, let's just continue for now. So giving again data, but considering the number of zeros that I have now, I should just remove the data log text again. Start collecting data, not here, here, and assemble some right. Give signal on here, push a button, push another button, and hopefully that motor is going to work as well, although I don't see it yet. So I cannot trust the signal that I get from the oscilloscope, at least not on the yellow channel. And I realize, by the way, that the colors are quite off, which is not good. Anyway, this is yellow, this is light blue, this is purple, and this is dark blue. So why the camera doesn't detect it, I do not know. I have no clue, to be honest. It's not good, so I have to check on it. Anyway, I have hopefully sufficient data by now. So let's examine. 1000, 1002, 1003, and I have 1001 as well, which is perfect. So now new window, and I'm going to copy the new one to the system. And of course I need the password. No, that is correct, because it is MNT. I need another password. That's better. So now for Octave, and I have here if else's, and I realize that is not going to work the way it does, the way it should, because everything well, if there's no data, it just goes on, so it is not a perfect script by any means. But let's just run it and see whatever happens. Oh, this is nice. At least I do have 3 graphs. Last time I ended with no graphs, so that's an improvement. But again, no phototransistor stuff, and that is a disappointment, because this one shows signal. That can also mean that the signal, because let's face it, how big is it? It is about 2 volts. And probably that 2 volts is seen as 0. So that I would have, okay, let me just cancel this one. Looking here at here, so now the signal is, oh look, now it is 5 volts, 4 volts suddenly. and I know why. Alright. The problem is with this lamp, it doesn't look like it, but it is not equally bright. So now when I let it lean this way, it gives full power. So if I now once again remove the data log and give this, remove the data log again because there are zeros in it. Now once again give some nice values, press the button a few times, then and of course I have to look right here. Sorry for the moving camera, but you know that I want to show you everything. So no signal on the oscilloscope doesn't mean in this case that there is nothing. And now this LED is showing, very nice. This LED is showing. I just will assume that the motor is running for the other one, but I don't need the motor right now. So in this case, how does it look? I have 1001, 1003, 2 and 0. That is alright. So going here, and this data is going very fast, so I just copy this one, being finished or not, I don't mind right now. I have some data. This is void. I can't even cancel it, so I have to cancel it here. Now it's gone, and I need to run it again, and I have nothing. Surprise, surprise. Really? Now that's a surprise. I have nothing. Again. How is that possible? Except for a nonsense figure like this one. But I do have data. So yeah, well, what this motor is doing, I don't know. But you can see that the data is still accumulating. So let's run it again for whatever it's worth. Now the data is gone. Go to Octave back and run it. You're kidding me. Still nothing. Okay, that I can't explain, because I really do have data here, and lots of it. So this is the newly copied data. Yeah, okay, there are quite a few zeros to end with, but you can see that this is still valid, very valid. These values are exactly the same as in here. You can see that. So why it doesn't show anything in here, I have no idea. Obviously something goes wrong, but what? That's another question. And with this result, or more appropriate results, I want to wrap this video. So despite the fact that on the USB stick from the data, it's very good data, all data that I want is there. Well, at least 1000, 1001, 2 and 3, they are there. Then a better solution for this. Let me put away the light for now. Unfortunately, this doesn't work. Then I noticed that this entrance right here somehow is broken. It's not completely broken, but something is still very odd. And that leaves question for, well, what? How to continue? Also, this one is being detected, well, on the oscilloscope at least. But why is it? But without the graph, I can't even tell it is there, because the phototransistor shows absolutely nothing, unless my program in Octave is wrong and that it shows something else but phototransistor. That is a possibility. I will have to check. However, I'm glad that this one works and that this one works. These work as well. These for now are, well, not really active. Oh, and of course one wire improvement to the correct port. So I have to press it to let it burn, and it doesn't burn automatically. So that's good. And with that, I say thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. And please, if you like what you see, including everything that goes wrong and is not intended, because I do not intend things to go wrong, but they happen to do. Please make a small donation via PayPal or Wired, and or become a patron and have your name mentioned as a supporter. For more information, and all information actually, please see my website under this video. This is going to be continued, so have a nice day and bye bye.